Welcome students to online classes of mathematics for class 8. In this video we are going to study the chapter number 3, which is understanding quadrilaterals of NCERT textbook, and we will try to cover the exercise 3.4. This is our session number 6 for this particular chapter. Myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The chapter number 3, understanding quadrilateral, in total have 5 subtopics which are listed here, after which we have already covered the first 4 subtopics in the previous sessions. Okay, today we are going to look at these some special types of parallelogram, that is some special parallelograms. Okay, so these are the 3 types. There are 3 types of special parallelogram. First one is a rhombus, second is a rectangle, and third one is a square. You've already studied about the quadrilateral family. We have the general quadrilateral, which are of 3 types. First one is a trapezium, second we have kite, and then we have parallelogram. And then in the parallelogram there are 3 types of special parallelogram. First one is a rhombus, then we have a rectangle, and the third one is a square. Okay, now we'll look at the all of them one by one, and we'll discuss about their properties. So first we have rhombus. The general definition of rhombus says a rhombus is a special type of parallelogram with all 4 sides of equal length. Okay, rhombus is a special type of parallelogram. Like I said, there are 3 types of special parallelogram: rhombus, rectangle, and square. So rhombus is itself a parallelogram, but it has a special property, which is its all 4 sides are of equal length. That means we have this parallelogram. This is a general shape of a parallelogram in which opposite sides are equal and parallel. If we shrink these sides, so this will become a shape like this with all 4 sides equal, and this will be called rhombus. Okay, so it was a parallelogram. When we shrink these 2 sides, okay, so this will become a figure like this, and this is called a rhombus. That's what it's written here. A rhombus is a special type of parallelogram with all 4 sides of equal length. That means if you see in this figure, the side AB will be equal to side BC, will be equal to side CD, and equals to DA. That is, AB is equals to BC is equals to CD is equals to DA. The all 4 sides are of equal length. Okay, then we have some properties of rhombus. The first property of rhombus is all 4 sides are of equal length, which is written here, that AB equals to BC equals to CD equals to DA. That means all 4 sides of a rhombus are of equal length. Second one is we have opposite sides are parallel. That means this opposite side AB is parallel to DC, and this side BC is parallel to DA. Okay, that is AB is parallel to DC, and side CB is parallel to DA. Okay, so these sides are parallel. Then we have opposite angles are equal. That means the angle A will be equals to angle C. Similarly, angle B will be equals to angle D. That is, angle A is equals to angle C, and angle B is equals to angle D. Okay, fourth one is the diagonals of a rhombus are perpendicular bisector of each other. Perpendicular means they intersect each other at the 90-degree. Bisector means they divide each other into the equal halves. Okay, they intersect each other at the angle of 90-degree, and they divide each other into equal halves. That means that this portion OD will be equals to OB. Similarly, this AO will be equals to OC, and they intersect each other at the angle of 90-degree. That is, the angle here is 90-degree. Okay, one more thing about the rhombus, that the 2 diagonal AC and BD are not equal. That means the length of diagonal AC and BD is not equal. Okay, you can write it as AC is bigger than BD from this particular figure. Not always, but in this figure AC is bigger than BD. Okay, so this is a general definition of rhombus and its property. Now moving ahead to the next special parallelogram, which is a rectangle. Rectangle is a parallelogram. Like I said, it's a special type of parallelogram with equal angles. In rhombus we have equal sides. Okay, in rhombus we had equal side, while in a rectangle we have equal angles. Okay, like again, when we have a general shape of a parallelogram like this, okay, in which opposite angles are equal, but if we move this side to slightly like this, so this will become a figure like this, and its all four angle will be of equal length, that is 90 degree each. Okay, so a rectangle is a parallelogram with equal angles. So that's the special type of a parallelogram with all angles equal, and this is known as a rectangle. Okay, so the properties of a rectangle are all four angles of a rectangle are of equal measure, that is all four angle A will be equals to angle B will be equals to angle C equals to angle D, that is angle A will be equals to angle B will be equals to angle C will be equals to angle D, and each will be of 90 degree. Okay, second one is opposite sides are equal and parallel to each other. These opposite side AB is equals to DC, similarly DA is equals to CB. They are equal and parallel. Opposite sides are equal and also parallel. That means AB is equals to DC and AB is parallel to DC. Also BC is equals to AD and BC is parallel to AD. So the opposite sides are equal and also opposite sides are parallel. Okay, next we have the diagonals of a rectangle are of equal measure and also bisect each other. These two diagonal AC, this one, and BD are of equal length. That means it says diagonals of rectangle are of equal measure and bisect each other, which means the diagonal AC is equals to diagonal BD and they are bisecting each other. That means if we name this point as O, so therefore all the sides, that means this AO will be equals to OC and BO will be equals to OD. So these are the two equal parts, and since the diagonals are equal, that means we can conclude that AO is equals to BO equals to CO equals to DO. So from here we conclude that all four these part AO, BO, CO and DO are equal because two diagonals are equal and they are bisecting each other. That means each port section of this diagonal will be of equal length. Okay, so these are the properties of a rectangle. Now moving ahead to the next special type of parallelogram, which is a square. A square is a rectangle. So what is a square? Square is itself a rectangle with equal sides. So that means a square satisfy all the properties of a rectangle, just one special addition, which is its sides are also equal. Okay, in rectangle only the opposite sides are equal. Okay, in rectangle we had only the opposite sides equal, while in the square all four sides are equal. Okay, so a square is a rectangle with equal side. That means AB will be equals to BC will be equals to CA will be equals to DA. Also the angle AB will be equals to angle A equals to B and will be equals to angle C and will be equals to angle D. Okay, so these are the property of the square, that all four sides are of equal length. That is AB is equals to BC equals to CD equals to DA. Okay, then it says all four angle are of equal measure. That means angle A will be equals to angle B will be equals to angle C will be equals to angle D. Okay, then we have opposite sides are parallel to one another. Opposite sides are parallel to one another. That means AB is parallel to DC and BC is parallel to AD. Okay, then we have diagonals of a square are perpendicular bisector of each other. That means diagonals are again equal, that AC is equals to BD and they are also bisecting each other. That means again AO will be equals to BO will be equals to CO equals to DO. All four these section will be of equal length. So these are the basic definition, general definition and the properties of the special type of a parallelogram, okay, which are rhombus, rectangle and square. Now based on this we have two examples, then we will start the exercise 3.4. So let's do the example first. This is chapter number 3, understanding quadrilateral, and exercise 3.4, some special parallelogram. Before that, we have example number 7, which says RICE is a rhombus as given in the figure. Find x, y, z and justify your findings. Okay, we are given this figure in which we are asked to find the value of x, y and z. Can you locate x, y, z? We have x here, y here and z here. Okay, so let's start this solution. It says we have to find the x, y and z. So first we'll find this x. So write from figure, first we'll write in rhombus. In geometrical portion you will always write the first name of the figure. So we are working in the rhombus, it's given in the figure, in rhombus, and then its name RICE. Okay, in rhombus RICE, RC and EI are the diagonals intersecting at O as given in the figure. They are intersecting at O here. Okay, therefore this EO will be equals to OI. Why they are equal? Because we'll write the reason here, which says the diagonals of a rhombus bisect each other. Diagonals of rhombus bisect each other. That's why they are equal, because this diagonal RC is dividing EI into two equal parts. That means EO will be equals to OI. So EO is given here as x and OI is given which is 5. So the x is equals to 5. Out of this expression we have calculated the x. Now we'll look at the y. Similarly, this side CO and RO will be equals to, that means RO will be equals to OC. Region is again same, that the diagonals of rhombus bisect each other. Okay, every time in the geometrical portion you have to write the region why they are equal. So RO is given which is y, and OC is also given which is 12. So the y is equals to 12. Now we have to find this z. You got this y. Now this z is here. So write from figure this RI will be equals to RE. RI will be equals to RE because they are the side of the rhombus. So write all four sides of rhombus are equal. Since the all four sides of rhombus are equal, that means RE will be equals to RI. So RI is given as Z and RE is given as 13. So the value of Z is equals to 13. So hence we have got the value of X, Y and Z. That's our answer. Moving to the next example, we have example number 8. It says rent is a rectangle. RENT, rent is a rectangle as given in the figure. Its diagonal meets at O. Find x if OR is equals to 2x plus 4 and OT is equals to 3x plus 1. Okay, so let's start a solution of example number 8. It's again very simple, like I told in the properties of rectangle, that in rectangle diagonals are equal and they bisect each other. That means first we'll write in rectangle, name of the rectangle is RENT. In rectangle RENT, diagonals RN and ET are intersecting at O. Okay, so in rectangle RENT, diagonals RN and ET are intersecting at O. From the properties of diagonal, we know that the diagonals of a rectangle are of equal length. So we have that RE will be equals to, sorry, RN will be equals to ET. Why they are equal? Because the diagonals of a rectangle are of equal length. Diagonals of rectangle are of equal length. That's why they are equal. Also, RO will be equals to EO will be equals to NO will be equals to TO. Why? Because the diagonals of a parallelogram, sorry, rectangle bisect each other. Diagonals of rectangle bisect each other. Bisect means divided in equal half. So since these are diagonal RN and ET are equal and they are bisecting each other, that means this portion of the line will be equals to this portion and this portion of the line will be equals to this portion. So all of them are equal. Okay, so we are given the value of this OR, we are given the value of OR, and also we are given the value of OT or TO. Okay, so we can write RO is equals to TO. We can write this TO or as OT as given here. Okay, so RO is given, which is 2x plus 4, and OT is also given, which is 3x plus 1. Now we have to solve this equation. Keeping this 3x here on the right hand side, will shift this 2x onto this side, so it will be minus 2x. Keeping this 4 here, will shift this plus 1 onto this side, will be minus 1. So 4 minus 1 is 3. On here we have 3x minus 2x is x. So the value of x is 3, and that's what we are asked to find. We were asked to find the value of x, which is turned out to be 3. Okay, that's the answer or the solution for the example number 8. I hope it's clear to you. Now moving to the exercise 3.4. This exercise total have 6 questions. Okay, we'll start with the first questions. It says state whether true or false. Okay, so first one is all rectangles are square. Let's start answer. Number 1, part A. It says all rectangles are square. You have to tell whether it's true or false. So it says all rectangles are square. We have a rectangle like this. This shape satisfies all the properties of rectangle, that opposite sides are equal and parallel. But in square there has to be all sides equal. That means, but here these two sides are not equal. So therefore in this particular case this cannot be stated as a square. So it's false. Okay, so why? This is a shape of a rectangle, and you can see in this rectangle that these two sides are, this one and this one are not equal. Okay, while is to be a square, the all four sides has to be equal, so it's false. Second, we have all rhombus are parallelogram. All rhombuses are parallelogram. So the answer for this one is true, because rhombus is a special type of a parallelogram. So answer for this one is true, because all rhombus are parallelogram, which is rhombus is a special type of a parallelogram. Okay, then part C, we have all square are rhombus and also rectangle. All squares are rhombus and also rectangle. This is also true, because a square satisfy all the properties of rhombus and the also of rectangle. So this one is also true. Then we have part D. It says all square are not parallelogram. All square are not parallelogram. This is false, because square is a special type of parallelogram. So every square is already a parallelogram. So this one is false, because it's written not here. If it is all square are parallelogram, then it will be true, but it said all squares are not parallelogram, so therefore it is false. Then we have part E. It says all kites are rhombuses. All kites are rhombus. So this is also not true, because a general shape of kite is like this, okay, in which adjacent sides are equal, but in rhombus all four sides has to be equal. So this one is false. Then we have part F, which says all rhombuses are kite. So all rhombuses are kite. So we have a shape of a rhombus like this. So this satisfies all the properties of kite, because adjacent sides will be equal, as the all four sides of rhombus are equal. One pair of opposite angle will be equal, and the diagonal will bisect each other at 90 degree. So our rhombus satisfies all the properties of a kite. So this one is true. Then we have G. It says all parallelograms are trapezium. It says all parallelogram are trapezium. So in parallelogram we have both pair of opposite sides equal and parallel, while in trapezium we need one pair of opposite sides parallel. So this satisfies the properties of a parallelogram. So this one is also true, because we have this parallelogram like this. Okay, in order it to be a trapezium, what we need only one pair of opposite side parallel. So this pair of opposite side will be parallel, so this can also be a trapezium. And the last one is all squares are trapezium. All squares are trapezium. So this is also true, because in trapezium we need only one pair of opposite sides equal, and in square we have both pair of opposite sides equal. So it is satisfying the properties of a trapezium also. So this one is true. Okay, so this is the solution of the question number 1. Moving ahead to the next question, we have identify all the quadrilaterals that have four sides of equal length. Okay, answer number 2, part A. We are asked to identify all types of quadrilaterals that have four sides of equal length. We have in two cases. First one is a rhombus and then square. Both are the quadrilateral with four sides of equal length. So write rhombus and square have four sides of equal length. Okay, so rhombus and square both have four sides of equal length. Then we have part B, which says identify all quadrilaterals that have four right angle. So in two cases, that is rectangle and a square, we have all angle of 90 degrees. So write square and rectangle have four right angles. Okay, so that's the solution of question number 2. Moving to the question number 3, it says explain how a square is a quadrilateral. Okay, let's write this answer. Number 3, part A. Part 1. Explain how a square is a quadrilateral. We know a quadrilateral is a shape which has four sides, and it has to be a closed shape. So it will be a quadrilateral. So we'll write a square is a quadrilateral since it has four sides. So any shape which has four sides and it has to be a closed shape, then it will be a quadrilateral. Okay. So square is a quadrilateral because it has four sides and it is a closed figure. Second, we have explain how a square is a parallelogram. Explain how a square is a parallelogram. In a parallelogram, we need one condition, which is opposite side has to be equal and parallel. So a parallelogram is square is also a parallelogram. In square also we have opposite sides equal and parallel. Therefore, it will be a parallelogram. And square is itself a special case of a parallelogram. So write a square is a parallelogram since its opposite sides are equal and parallel to each other. Okay, so we need only opposite sides to be parallel and equal to any shape to be a parallelogram. Okay, next one is explain how a square is a rhombus. So part 3, explain how a square is a rhombus. In a square and a rhombus, we have equal size. For all four sides are equal, and it says both have the equal sides and the diagonals bisect each other perpendicularly. So write rhombus and square. Rhombus and square are quadrilaterals whose diagonals are perpendicular bisector of each other. Okay, next one is explain how a square is a rectangle. Okay, a square also has opposite sides parallel and equal. In rectangle also opposite sides are parallel and equal, and in square all angle are of 90 degree, and in rectangle also all four angle are of 90 degree. So all right, square and rectangle are quadrilaterals whose diagonals are equal and all angles are of 90 degree. Okay, so in a square and rectangle all angles are equal, which are of equals to 90 degree, and the diagonals are equal. In square also rectangles are equal, and rectangle also diagonals are equal. Okay, so that's the solution of the question number 3. Moving to the next one, we have name the quadrilateral whose diagonals bisect each other. So let's write a solution. Answer number 4. We have to name the types of quadrilateral. The quadrilateral in which diagonals bisect each other. So we have rhombus, then we have parallelogram, then we have a rectangle and square. In all these four figures, the diagonals bisect each other. So rhombus, parallelogram, rectangle and square are quadrilaterals whose diagonals bisect each other. Okay, you can look at the figure of all three. You will find that diagonals are bisecting each other. That means dividing each other into equal halves. Next one is name a quadrilateral whose diagonals are perpendicular bisector of each other. We have two cases. One is the rhombus and second is the square. So we'll write rhombus and square are the quadrilaterals whose diagonals are, or we can write whose diagonals are perpendicular bisector of each other. Okay, so we have two cases. One is a rhombus and a square. In both one, the diagonals are perpendicular bisector of each other. Next one is name of quadrilateral whose diagonals are equal. So can you name them? We have again two cases. One is a square and the rectangle in which the diagonals are equal. Okay, so write square and rectangle are the quadrilaterals whose diagonals are equal. These are very important question because you will learn about the concept of the special parallelogram. Okay, so in which cases the diagonals are perpendicular bisector, in which case they are perpendicular bisector, and in which they are equal. Okay, these are the based on the property that we studied just before starting the exercise. Okay, so now next one is explain why a rectangle is a convex quadrilateral. Why a rectangle is a convex quadrilateral? Before that, you should know what is a convex polygon or convex figure. Like I told in the previous chapter that if the diagonals of a polygon or any shape, if the diagonals lie in the interior, then it will be called convex. If the diagonals or one of the diagonal lie in the exterior part, then it will be called as concave quadrilateral. So when we draw a rectangle, let's say this one, and let's draw its two diagonals, this one and this one. You will find that both the diagonals are lying in the interior. Nothing is out of these four sides. Okay, that's why this is called a convex quadrilateral. So we'll write answer number 5, it says a rectangle has two diagonals and both lies in the interior part of the rectangle. Okay, hence a rectangle is a convex quadrilateral. Rectangle is a convex quadrilateral. So I'll draw the figure of a rectangle. I'm drawing it roughly. You will draw it using pencil and scale, and it should be drawn neatly and cleanly. So this is a general diagram of a rectangle in which both of its diagonal will lie in its interior. Okay, I hope you understood. This is not taking this shape. Okay, so both the diagonals are lying in the interior, that's why a rectangle is a convex quadrilateral. Now moving to the next and the last question of this exercise and also from this chapter, it says ABC is a right angle triangle and O is the midpoint. We have this triangle A, B, C, okay, and O is the midpoint of the side opposite to the right angle. So this is a right angle here, and O is the midpoint of the opposite side. Explain why O is the equidistance from A, B and C. Okay, so what we have done here is we have extended this line. We have drawn a line AD, this one, which is equal and parallel to BC, and similarly this DC is equal and parallel to AB. Okay, so let's write the solution. Answer number 6. It says we have a right triangle we have a right triangle ABC, right angled at B, and O is the midpoint of the side AC. Okay, O is the midpoint of the side AC. So what we did here is, let's draw AD, which is parallel and equals to BC. Let's draw AD equals to BC and AD parallel to BC. Also we'll draw AB equals to DC and AB parallel to DC. Therefore ABCD is a rectangle. So after drawing this line, because these opposite sides are equal and parallel, so here also opposite sides are equal and parallel. Since this angle is 90 degrees, so its opposite angle will also be 90 degrees. Hence ABCD will be a rectangle. Okay, therefore we know that in a rectangle diagonals are equal and they bisect each other. So right, in right we know that we know that in rectangle diagonals are equal and they bisect each other. Okay, that is from the figure, since these two diagonals are equal and they are bisecting each other, it means this part will be equal to this one and will also be equal to this part. So that is AO will be equals to BO will be equals to CO equals to DO. Hence O is equidistant from AB and C. Hence O is equidistant from A, B and C. This equidistance means at equal distance. Okay, equidistance means at equal distance. Hence O is equidistant from AB and C. I hope this is clear to you. What we did is we have drawn these two sides AD and BC, which are parallel to their opposite sides and also equal to their opposite side. Hence ABCD is a rectangle, and we know that in a rectangle opposites, so in a rectangle diagonals are equal and they bisect each other. That means these will satisfy that AO is equals to BC equals to CO is equals to DO. Hence the point A is equidistant from A, B and C. Okay, so that's the end of the question number 6 and also the exercise number 3.4. With that we have finished the chapter number 3, understanding quadrilaterals. Okay, so what you are supposed to do is you have to practice all these questions, and also first you have to read and understand all these properties of square, rectangle and rhombus. Okay, so that's all for today's class. Thanks for joining here.